Application architecture refers to the design and structure of a software application or system. It encompasses the high-level decisions and patterns that determine how the various components and modules of an application are organized, communicate with each other, and interact with the underlying infrastructure. Application architecture serves as a blueprint for developers, guiding them in building scalable, reliable, and maintainable applications. It defines the overall structure and behavior of the application, including the arrangement of components, the flow of data, and the mechanisms for communication and coordination. Here are some key aspects and concepts commonly found in application architecture. Components. Applications are typically composed of multiple components, which are self-contained modules responsible for specific tasks or functions. Components can be organized in various ways, such as layered architecture, where components are grouped into layers based on their functionality. Communication. Components within an application often need to communicate and share data with each other. Communication can be achieved through various mechanisms, such as function calls, method invocations, messaging systems, or APIs, application programming interfaces. Data management. Applications often need to store and manage data. The architecture defines how data is structured, stored, accessed, and manipulated. This may involve databases, caching systems, file systems, or other data storage mechanisms. Scalability. Application architecture should consider the ability of the system to handle increased workloads and user demands. It involves designing the application in a way that allows for horizontal or vertical scaling, ensuring performance and availability as the application grows. Security. Architectural decisions should address the security of the application, protecting sensitive data and preventing unauthorized access. This may involve implementing authentication mechanisms, encryption, secure communication channels, and other security measures. Integration. Many applications need to interact with external systems, such as third-party services, APIs, or databases. Application architecture should define how these integrations are implemented, including the protocols, data formats, and communication patterns. Concurrency and parallelism. Modern applications often need to handle multiple tasks concurrently or in parallel. The architecture should consider how to manage concurrent execution, synchronization, and resource sharing to ensure efficient and correct operation. Deployment and infrastructure. Application architecture also considers the deployment environment and infrastructure requirements. This includes decisions about the hosting platform, server configuration, network topology, and other aspects necessary to run the application. Different architectural patterns and styles exist, such as monolithic architecture, microservices architecture, service-oriented architecture, SOA, event-driven architecture, and many more. The choice of architecture depends on factors like the nature of the application, the desired scalability, performance, maintainability, and the specific requirements of the project. Overall, application architecture provides a structured approach to designing software systems, helping developers create robust and flexible applications that meet business needs efficiently. For example, monolithic architecture. In this pattern, the application is built as a single, self-contained unit where all components and functionality are tightly coupled. It typically consists of a single codebase and is deployed as a single executable or deployment package. Monolithic architecture is straightforward to develop and deploy but can be challenging to scale and maintain as the application grows. Microservices architecture. In this pattern, the application is decomposed into a collection of small, loosely coupled services, each responsible for a specific business capability. Each service runs independently and communicates with others through well-defined APIs. Microservices architecture promotes scalability, flexibility, and independent deployment of services, but it adds complexity in terms of inter-service communication and infrastructure management. Service-oriented architecture, SOA. SOA is an architectural style that focuses on building applications by composing loosely coupled, reusable services. Services in SOA can be independently developed and deployed, and they communicate using standardized protocols such as SOAP, Simple Object Access Protocol, or REST, Representational State Transfer. SOA enables organizations to integrate different systems and applications, promoting interoperability and reusability. Event-driven architecture. This architecture pattern emphasizes the production, detection, and consumption of events as the primary means of communication between components. Events represent significant occurrences or changes in the system and can trigger actions or workflows. Event-driven architecture is often used in real-time systems, event processing systems, or complex event processing (CEP) scenarios. Layered architecture. Layered architecture organizes the application into logical layers, where each layer provides a specific set of functionality. Typically, layers include presentation, user interface, business logic, and data storage. This pattern helps to achieve separation of concerns and modularity, making the application easier to understand, maintain, and test. Client-server architecture. This architecture divides the application into two main parts: the client and the server. The client, often a user interface, interacts with the server, which processes requests, performs business logic, and manages data storage. Client-server architecture is commonly used in web applications, where the client is a web browser and the server is responsible for serving web pages and handling requests. These are just a few examples of application architecture patterns, and there are many other variations and combinations based on specific requirements and use cases. It's important to select the appropriate architecture pattern that aligns with the goals, scalability needs, and constraints of the application being developed.